Welcome to The Explainer. We're jumping right into something truly fascinating today, something that sits right at the very heart of our modern digital world. I mean, if you look around the tech landscape right now, from those massive web apps to the absolute cutting edge of AI, there's basically one language running the whole shebang, Python. But what if I told you that the true purpose behind the world's most popular programming language actually had very little to do with machines and everything to do with you? We're going to unpack the surprising true architecture of Python, and I promise you, it's going to completely change how you look at software design.
So, what was Python's greatest innovation? I want you to think about what normally makes a technology totally dominate the world. We usually just assume it must be the absolute fastest, or the most academically pure, or just the most powerful tool for compiler researchers. But the secret behind Python's massive success actually defies traditional computer science entirely.
The answer isn't what you'd expect. Python's greatest innovation wasn't technical at all. It was psychological. The language's creator, Guido van Rossum, made a really radical choice back in 1989. He optimized programming for human minds, not just machines. He didn't want to create the fastest language out there. He wanted to create a language that felt natural, reduced unnecessary complexity, and most importantly, allowed humans to actually communicate ideas clearly.
Okay, let's dive into this. Section 1, the psychological paradigm shift. And this brilliantly illustrates the historical problem he was trying to solve. Back in the late 80s, the programming landscape was, well, it was kind of a mess. You had C, which was incredibly powerful, for sure, but famously dangerous to work with. Shell scripting was messy. Perl was wildly flexible, but, notoriously hard to maintain. Languages back then were strictly about sending instructions to a machine, often completely at the expense of the poor human typing them out. Just compare a traditional C-style syntax with Python. In traditional languages, you're dealing with parentheses, curly braces, semicolons. It's visually dense, right? But in Python, it's just if x is greater than 5, print x. It literally reads almost exactly like English. Guido intentionally removed all that visual noise. By ditching the structural clutter, Python immediately drops the cognitive load on the programmer. You aren't constantly decoding symbols, you're just reading logic.
It's actually fascinating how programming languages directly reflect the personalities and the priorities of their creators. Like Dennis Ritchie designed C with the philosophy of trusting the programmer completely, giving them total control, but also total risk. Bjarne Stroustrup focused C++ on zero-cost abstraction. James Gosling built Java around safety and portability across different operating systems. But Guido van Rossum, his ultimate goal was readability and human simplicity. He viewed programming as a way for humans to communicate ideas, essentially treating human comprehension as the ultimate metric of success.
Which brings us to Section 2, Designing for Human Minds.
So the crucial point is, how do you take that abstract philosophy of human simplicity and actually bake it into the DNA of a programming language? It requires making some incredibly bold architectural decisions right from day one. To optimize for human minds, Guido built his entire architecture around one defining truth: code is read far more often than it is written. Most languages at the time were optimizing for compiler simplicity or machine execution speed. But by acknowledging that developers spend way more time reading existing code than writing new lines, Guido treated readability not just as a nice stylistic preference, but as a primary, foundational language feature. This was a revolutionary shift in thinking.
In fact, this philosophy is literally documented right inside the language itself. It's called the Zen of Python. You have tenets like beautiful is better than ugly, meaning good code should feel structurally balanced and intentional. Explicit is better than implicit, which means avoiding hidden magic behaviors that make debugging an absolute nightmare later on. And simple is better than complex. Guido intentionally excluded a lot of clever language tricks because, well, they encourage cryptic, over-engineered code. He just wanted a clean blueprint for human thought.
Moving right along to Section 3, Radical yet Simple Architecture.
Now, optimizing for the human mind meant Guido had to make some very unconventional structural decisions that actually got mocked quite a bit in the early days. Perhaps his most famous and initially controversial move was using indentation as syntax. In most languages, programmers use curly braces to define blocks of code, but then they indent anyway just to make it readable for themselves, totally relying on their own discipline. Guido realized this was just redundant. If we're already indenting to make it readable, why duplicate the structure with braces? Python just uses the indentation itself to tell the computer what the structure is. It removes visual redundancy and ensures that the language automatically guides good behavior. The structure is visible immediately, plain as day.
Another radical architectural idea was the batteries-included philosophy. Python shipped with this massive standard library right out of the gate: networking, regular expressions, JSON, testing frameworks, database connections. Why do that? Because Guido wanted developers to be productive immediately. He didn't want human minds wasting precious cognitive energy hunting down fragmented third-party tools just to get basic, everyday tasks done. It made the language feel complete and highly practical the second you installed it.
Let's move to and see how this builds into Section 4, the ultimate glue language.
As we shift from the syntax of the language itself to the broader ecosystem, we start to see how Python's design allowed it to interact with the rest of the computing world. A lot of people love to point out that Python isn't the fastest language for a computer to execute, and that's true. But Guido never meant for Python to replace incredibly fast, low-level languages like C. Instead, the design was brilliant in how it delegated tasks. Python orchestrates, and C accelerates. Python acts as the highly readable, high-level control layer where the human does the thinking, while all the heavy, repetitive mathematical computation sits underneath in much faster languages.
This hybrid architecture is exactly why Python is the foundation of modern technology today. Heavy computation is pushed down into C, C++, or even Fortran. This creates the backbone for massive industry-standard libraries like NumPy, TensorFlow, and PyTorch. Because Python is so extension-friendly, it became the perfect glue. You get the incredible raw execution speed of low-level languages, perfectly combined with the cognitive speed of Python's human-readable syntax.
All right, Section 5, hard choices and leadership. You know, a programming language is really only as good as the community and the governance that maintains it. So how did Python keep this human-centric philosophy completely intact through decades of massive evolution in the tech industry? Well, it came down to a very unique governance model. For a really long time, Guido held the title of BDFL, which stands for Benevolent Dictator for Life. This basically meant that while Python was heavily community-driven and open source, there was always one final decision-maker. Programming language design can so easily become a chaotic mess of competing features, but Guido's ability to simply say no to features that harmed readability, that is what maintained the language's coherence and simplicity for decades.
And sometimes, that leadership required making some incredibly painful choices, like the transition from Python 2 to Python 3. It intentionally broke backward compatibility. Code written in Python 2 wouldn't just automatically work in Python 3. It was a massive headache for the community. People were not happy, and the ecosystem really struggled for a few years there. But Guido forced this change because Python 3 cleaned up fundamental inconsistencies and legacy junk. He chose the long-term health of the language over short-term convenience, and honestly, that's what secured Python's future.
Which leads us perfectly into Section 6, why Python rules AI.
To really understand Python's absolute dominance in AI, we have to look at a seemingly trivial detail. Why the name Python? You might think it has something to do with the snake, right? Maybe an allusion to something fast or sleek or dangerous. The truth actually reveals the absolute core of Guido's welcoming philosophy. He actually named it after Monty Python's Flying Circus, the legendary British comedy show. This wasn't just some quirky trivia fact. It demonstrated exactly what Guido wanted programming to feel like. He wanted it to be approachable. He wanted it to be creative. He desperately wanted it to be less intimidating.
Now, what's really interesting about this slide is how that playful culture just completely permeated the entire ecosystem. If you read Python documentation, the placeholder variables aren't just dry, boring mathematical terms like x and y. They use spam, eggs, and ham. The examples are intentionally playful and silly. This stands in stark contrast to the rigid, hyper-formal, enterprise-heavy languages that absolutely dominated the 90s and 2000s. Python actively wanted to be friendly to the human using it.
And honestly, that friendliness is exactly why it conquered the world of artificial intelligence. Think about the people building AI: scientists, researchers, data analysts. They wanted ideas first, engineering second. They aren't traditional software engineers by trade. Their primary job isn't wrestling with computer memory allocation or obscure syntax errors. Because Python prioritized dynamic experimentation, interactive scripting, and rapid iteration, it perfectly matched their workflow. They could learn it quickly, the syntax stayed completely out of their way, and they could test really complex mathematical theories basically at the speed of thought. Which leaves us with this final, incredibly powerful thought. Most languages ask, how can humans adapt to computers? Python asked, how can computers adapt to humans? When you look at the complex digital infrastructure running our world today, remember that the foundation of it all isn't just raw processing power. It is a brilliant architecture of human cognitive efficiency.
Python won because it understood that the most valuable resource in computing isn't memory or processing cycles. It's human clarity. So think about that the next time you boot up an app or look at a piece of software. What else could we completely transform if we just focused on optimizing for the human mind? Thanks for exploring this explainer with me.